All right, section 10.2. Now we are solving inequalities. And solving for inequalities are very similar to solving for variables when they're equations. The only difference is a very specific, only one other situation. So we're going to use these different examples and we're going to solve them, and then we're going to try to match it with their graph. So number one, we have y minus 2 is greater than or equal to 7. So we're going to add 2 to both sides. We get y is greater than or equal to 9. So it's greater than or equal to, so we're going to look for a closed circle over the 9, and that would be D. So D has a closed circle at 9 and going to the right because that would be greater than. Number 2, we have 10 is less than z plus 8. We're going to subtract 8 from both sides. We get 2 is less than z, and this is where most students will make their mistake. They will think that it has to be an open circle going to the left because it's less than. But we have to always write our variable first, and notice the inequality is eating the z. So when I rewrite it with z coming first, it's still eating it, and z represents my solution. So I always say that my solutions are greater than 2. So I have an open circle over 2 and going to the right. So I'm looking for an open circle over 2. Going to the right would be letter A. And the next problem, we have multiplication. 6p is less than 24, so we're going to divide both sides by 6. We get p is less than 4. Open circle over 4 going to the left. So that's going to be J. So we had A, we've had D, and we've had J. Number 14, same thing. This time we're going to divide both sides by 6. 18 is less than or equal to 6v. Divide by 6, divide by 6. 3 is less than or equal to v. Again, I'm going to rewrite it with my variable first. Closed circle because it's equal to over the 3 going to the right, and that would be h. I'm going to erase this work. And I'm going to continue. This is a good one. So this is the first one where we have a negative coefficient when something's being multiplied by the variable. So the rule is if we ever multiply or divide both sides by a negative number, we have to flip the inequality sign. So it's a greater than, we're going to flip it to a less than. And this is where students again get messed up. Now we have to write our variable first, so we have to flip it again. So we get m is greater than 4, open circle, which is b. Our next problem is d divided by 2 is greater than negative 10. We're going to multiply both sides by the reciprocal. We get d is greater than negative 20. Notice we have a negative value, but we didn't multiply both sides by a negative. We multiply both sides by positive 2. So will not flip the inequality sign. We have d is greater than, open circle, negative 20. So we look for negative 20, and that would be G. We'll erase these. And we have 2 minus G is greater than 0. We're going to subtract 2 because it's a positive 2. That negative is attached to the G. We have negative G is greater than negative 2. We're going to multiply both sides by negative 1. We're left with G is less than 2. Because we multiply both sides by a negative, we're going to flip that inequality sign from a greater than to a less than. So G is less than 2. Open circle 2 is E. Next problem that we have is 3 is less than or equal to x over negative 2. Multiply both sides by negative 2. We get negative 6 is less than or equal to x. Let's write our variable first. Make sure that when you flip it, when you change x to the other side, that you also change your inequality. So greater than or equal to negative 6. We're going to have a closed circle over -6, and it's going to be going to the right. Look at F. F is very interesting. So where did I make a mistake? I don't see a -6. I see I, but that's not a correct answer. I see C, which I see where that's going, but I don't see I. Let me make sure I wrote the problem properly to begin with. I didn't flip the inequality sign here. I multiplied both sides by -2, and I should have flipped it. And now, when I rewrite it, I make sure that it's eating the -6 before. It's eating the -6 here. So I need to make sure it's eating the -6 here. So it is I. And because it didn't make sense, I had to go back and check my work. When I checked my work, I found my mistake. So that's extremely beneficial for us. These last two are good because they happen about 1% of the time. We have b minus 1 is less than b minus 2. We're going to subtract b from both sides. Notice that the variables cancel, and it produces a true or false statement. -1 is less than -2. That is a false statement, so it's going to be no solution. So when variables cancel, two things can happen. You can write a true statement, or you can have a false statement. In this case, it's a false statement, so there's no solutions, and that would be F. Notice nothing is graphed on that number line. And on the flip side, when we subtract t, we always move the variable first. 2 is greater than 1. That's a true statement, so all real numbers, meaning we can plug in any number on the number line to make that statement true, and that would be C. And we notice that it is graphed like that.